Welcome. In this tutorial, we will learn how to read data from a file and save into a database. To achieve this objective, we will use the scanner class object to read the stored data from a file. We will learn how to create a MySQL database and a database table for saving the information. After that, I will show you how to connect with a MySQL database. We will learn how to query a MySQL database for saving and displaying data. At the end of this tutorial, I will demonstrate to show you how to handle different file reading issues and their solutions. Before we go further, we need to create a Java class file, which will contain the source code, for the purpose of the subject task. Now import the required classes such as File class, IOException class, Java SQL package and the scanner class of the Java utility package. Notice that we are importing the entire Java SQL package, because we need various classes of this package. An asterisk is a shortcut way to import all the classes in a Java package. We have created an employees class, which will read and store data about employees. For this demo purpose, we need information about an employee's name, salary and the department ID. Now create a method which will read data from a file and saves the information into the database. We open the data containing file into the try with resources statement, which will handle file opening and closing automatically. In case of an input-output exception, it will catch the appropriate exception as well. Create a text file with some dummy data for reading purpose. Specify the path of the file, from which we will read employees' data. By using the scanner class object, we will read the file, line by line in a while loop. The hasNextLine method of the scanner object ensures by checking whether there is a line to read. If it is, then Boolean true is returned to keep the loop running. Otherwise, a Boolean false will cause the loop to stop. The nextLine method reads a line of text from the file and returns as in string object. We store it in the string variable called line. This process is called line-based processing. Now create a scanner object by referring to the string object line, for reading the data word by word. This process is called token-based processing. To read and save the name of an employee, we have to run a loop, because each name may contain more than one words. As the name of an employee is of type string, therefore, we concatenate each word by running the loop, until an integer type is not detected. Notice that a space string is also being concatenated with the employee name. This is because the next method truncates any white spaces following a word. After reading an employee's entire name, we remove white spaces at both ends of it with the trim method. To read the salary data, we must check for an integer data input, otherwise, an input mismatch exception is generated, if the input data is not an integer type. Now get the last data item of the employee record, the department ID, which is also of type integer. At this point, the scanner data object finishes reading an entire employee record from the string object line. The while loop will reiterate, if there is another record available. We should check the read data here for debugging purpose. Now create a class for evaluating the employee class. This class will create an object of the employee class for data manipulation. We execute the public methods of the employee class inside the try-catch exception handler. In this handler, we will catch for any runtime exception, which is not caught by other try-catch blocks. The exception class is used to catch any exception, which is not related with the JVM. All the data are displayed successfully. Now click on the Services tab to start the database server to perform database operations. By default, the JDK comes with a small database server called JavaDB, but in our case, we have already installed MySQL Database server on our system. Create a database and a table, in order to store the data. We create an employee table with 3 fields, employee name, salary and the department ID. The newly created table has no data yet, but it will contain later on. In order to execute SQL statements from within a Java program, we need to add the MySQL JDBC driver into the libraries folder of our project. It is a jar file short for Java archive, contained in a zip file. It can be downloaded from the MySQL's website freely. Now create a method that returns a connection to the database for executing SQL queries. We declare this method with the private access modifier for restricting the access outside the class, because it is only needed inside the class. It is optional to load database driver, because starting with JDBC version 4, which is part of Java 6, Java automatically loads a database driver. To create a connection, we use the getConnection method of the DriverManager class. The getConnection method takes the database URL, username and password as arguments to connect with a database. An SQL exception is generated when a connection fails connecting to a database. While loading a database driver, a class not found exception may be generated, if the driver does not exist. We return null, in case of a connection failure. Now create a method that saves the data read from a file. We declare this method also as private, because we allow the data saving operation only from within the class. A database connection is declared with a try with resources statement, will be closed automatically. We create a PreparedStatement object using the PreparedStatement method in the connection interface. PreparedStatement enables us to create parameterized SQL statements. Prepared statements help prevent SQL injection attacks, which typically occur in SQL statements that include user input improperly. The question marks in the query string are placeholders for values that will be passed as part of the query to the database. PreparedStatement interface provides us setter methods for each data type that set the parameter values in the query string before executing SQL statements. The method setString sets a string value to the specified parameter. A parameter index starts from 1. The setInt method sets an integer value to the specified parameter. After setting the parameters, we can execute the prepared statement by invoking executeQuery method for a select statement and executeUpdate method for a DDL or update statement. The executeUpdate method returns an integer indicating the number of rows that were updated or inserted in the database, whereas the executeQuery method returns the query result as an object of the ResultSet interface. Now save the data into the database by invoking the SaveData method. This method will be called for each employee record in the loop until all the lines of records are not read from the file. Now run the file. The program is executed successfully. Now check the database for newly inserted employee records. The data from the file have successfully been inserted into the database. Now create a method that retrieves the employee records from the database. Using a try with resources statement, we open a connection to the database by calling the connect method we created earlier. We also create a statement object for executing SQL statements. This method will also catch for SQL exceptions. The execute method of the statement object will return a Boolean value after executing the query string. We will check for a Boolean true before saving the query results in a ResultSet object. If the condition is true, then we create a ResultSet object to store the results of the query by calling the method getResultSet. We also access the metadata of the ResultSet, using the ResultSetMetaData interface object. Metadata are data about an object. ResultSetMetaData describe the properties of a ResultSet. A ResultSetMetaData object provides us information about column count and column names of a table. We get the number of columns by calling the getColumnCount method. This will help us to run a loop and display the column labels. The getColumnLabel method returns the name of a column, as specified by the as clause of an SQL statement. If not specified, the actual title of the column will be returned. Now we run the loop to iterate through each row of the ResultSet table. The next method points to the next available row. It returns true if a row exists, otherwise false. The initial row position is null. The various getter methods of the ResultSet interface enable the program to manipulate the query result. Comment off the SaveData method, so that duplicate records may not be inserted into the database, because we only want to check for retrieval of the data from database. The data are displayed successfully. We should format the data slightly with the printf function. The printf function allows us to format data using the format specifiers. What will happen if we add a few empty lines into the data file? Let's check it. Remove all the data from the database. Now add some empty lines to the file. Uncomment the SaveData method, so that the data be added to the database. Now run the file. Notice that the no such element exception has occurred. This is due to the empty lines we added to the file. The solution to the issue is that we must skip the empty lines dynamically while reading data from a file. For that we add an if statement to check for empty lines. If a line is empty, then reiterate the loop by executing the keyword continue. Now run the file. Now the program runs successfully without any no such element exception. All the data have also been written to database. To check the functionality of the program further, we add an employee record to the source file that contains a name with the size of 1 word. In order to avoid data duplication, we remove any previous inserted data from database. This is just for testing purpose. The program is perfectly executing without any exception. That's it. Thank you for watching my video. Hope that it has added some information to your knowledge. Please don't forget to give your feedback by liking the video and subscribing to my channel.